welcome to a new video. In this video, we're going to talk about exception handling. Exception handling is a very important concept in programming in general, any programming language. So what is exception handling? Well, whenever you have a project or your program you're working on, when you finish working on that project, what do you need to do? You need to make sure that that project is working 100% fine with no errors and no problems that could happen. But in reality, errors could happen. There's a lot of resources for errors that could happen. For example, the user could enter a value that's not acceptable, or the program is reading a data from a memory location and that memory location, let's say, was damaged, or you're reading a data from a sensor and that sensor is providing you data that's not acceptable. So what I'm trying to say here, there's a lot of possibilities, a lot of scenarios where your project and your program can go down, it can go wrong, and can crash down on the user. So when you design a project and after you're done with the project and your idea and everything, after that you need to go ahead and start a testing phase. And in this testing phase, basically what you're going to do, you're going to try to run the program for many hours using different users, trying to find out if there's anything wrong with your project. And if any time an error will raise, basically you need to have a solution for that error. So how do we do that? Basically, there's a mechanism for that process called exception handling. And companies usually provide users with a beta version, and they ask them to test the product for a month or two. And what's going to happen, basically, every time an error happened at the user end, that error message is going to be sent back to the company, so the company will handle that error. So the question is, how do the companies handle those types of errors? Basically using what we call exception handling mechanism. So to explain that concept, I'm just going to go through this very simple scenario that I have here. I do have a variables that I created, A and B. I have an array of 5 values, 1, 2, 3, 4, 5, and then I have an index value that I'm going to use to have access to those values. And then I have a variable called string, called name with a type of string. What I'm going to do, I'm going to ask the user to enter 2 values, and then I'm going to divide them by each other. And then after that, I'm going to ask the user to enter a value, which is whatever he's going to enter, which is index. And then I'm going to try to manipulate the value of index. For example, if he entered 0, so I'm going to convert the 1 to 100. If he's going to enter 1, I'm going to change the 2 to 100, and so on. And then after that, I just ask the user to enter a name, and I'm going to print it on the screen. So if I run this project here, I'm just going to enter 2 values, and then I'm going to enter a value here. And then after that, I'm going to type A, B, C. And you can see here there's nothing wrong with the code that I created. Now let's start talking about scenarios of something can go wrong. The first thing I'm going to talk about is, what if I entered 0 for the second value? Here we go. The program just crashed. Why did it crash? Because again, in programming, you're not allowed to divide by 0. And if you put the mouse here, it's going to tell you, this is very important, unhandled exception. That basically means an exception happened and you didn't handle it. And that section, basically, you're trying to divide by 0. So you're not allowed to do that. Okay, let's see the other case. I'm going to enter same values. Here, I'm going to enter the value of let's say, 87. Oh, look at that. It worked. Let me just wait for it. ABC. And here we go. That's what I was waiting for. Well, actually, that worked perfectly fine with no problems. That should not be the case. Let me try to run it again. Enter a value of the array. Let's go for 122. I just tried it a few minutes ago and it didn't work. Again, what I'm trying to say here, let me just go back to this assumption. I entered the value of index, and the index value is represent which one of those values I can have access to. When I enter the value that's too big for the index and I try to change it to 100, the program should crush. You're not allowed to do that usually, but for some reason this program is not crushing. That's weird. Why is it should crush? Because again, when I typed 100 here, I'm having access to a memory location with a specific address. Now that specific address could belong to another program or could not belong to another program. If that memory address that I'm trying to have access and change it to 100, if it belonged to another program, that basically means I'm trying to have access to a data for another program from another program, and that will mess up the other program. So the operating system should not let me to do that. But again, I guess in that space is not used by any other software, so that's why it's letting me do it. But again, usually it should not allow me to do that. So I don't want to take chances here. But again, if I run it again, let's try to have a different value, for example, 12 and 6. And let's try to have something really big. That's exactly what I was expecting. It's telling me that an exception was thrown because, again, that memory location that I was trying to have access to, which is, I believe, this one, I do not have access to it. It belongs to another program. Okay, so as you can see here, I entered the index value with a value and it was okay, and I entered with another value, and then boom, the program started yelling at me. You should not take chances, of course. Let's start with that. So you should also have in your mind that you should never exceed or pass the limit of the values that you have here. So that's another type of errors that could happen. So what do we have to do in this case? Well, we need to include, this is a perfect case to include or to use exception handling. So let's talk about the syntax of exception handling, and then I'm going to talk about how does it work. First thing first, you need to specify the block of code that you think errors will happen through them. And I'm expecting that the error will happen in this area. And then at the beginning of the curly brace, you just type try. Try basically means you're telling the compiler that something can go wrong in this area. And then you need to look at the area where you think something can go wrong, and you have to go and study them one by one. So there's nothing can go wrong here. I'm asking the user to enter two integers. Again, the user can enter a value that is not an integer. That's a type of error that I'm not going to talk about right now. I want you to think about it. What if the user entered a string instead of an integer here? How the program should handle that? Well, there's an exception case for us, but I'm not going to talk about it right now. So I know that the error could happen here in this area. So what you should do, you should come here and type an if statement, and we'll say if b actually equals 0, then something has to be done. Otherwise, just keep going. This is a place where an error could happen. Now, this area here, it's also a place where an error could happen. So I'm just going to go here and type if index is actually greater than 4. Then something should happen here. So I will avoid accessing to a number that's greater than 4. In this case, I'm not gonna talk about this one for now. So now that I know that an error could happen here and an error can happen here, this is what I need to do. You need to come here and type throw. And then, for example, I'll just throw b. And b is an integer. And here, I'll just say throw index. Now this is not going to work for some reason, and it's not going to work. There's a reason. I just made a mistake here, and I'm going to show you what it is, and I'm going to show you how to fix it. Now, after you throw those values, which basically what we call throw exception, you need to catch that exception. So you come here and type catch, and I'm going to have two catches here. One of them for the first error, and the second one for the second error. And also I can have a catch. It's not specified catch. It basically means if any error that you didn't take under consideration, use this block to catch it. Okay, now we need to go and talk about what are we supposed to do in this area. Well, for the first error, I'm throwing b. What is a b? B is an integer, so I have to come here and type integer e1. And here I'm just going to type a message, cout, do not divide by 0 with an angry tone. And here, this is again where we're going to have an issue and we're going to have a problem. Since this is an integer, I cannot throw another integer here. Why I can't? because how can the compiler know which one of them to call? So what I'm going to do to fix this problem, even though this is not the perfect way to do it, I'm just going to type index multiplied by 1.0. So what am I doing here? Multiplying an integer by a number with a decimal point. I'm converting it to a number with a decimal point so the compiler will understand what it is. So I'm going to come here and type double E2, and I'm going to say cout index should not be greater than 4. You entered, and I'll just put E2 and line semicolon, and put semicolon here. And this is where we go. We call it the generic one. Something happened. Not sure what it is. Not sure what it is. I put semicolon here. I'm going to talk about this case later. So let's go back here. So if you decided to enter b to be equals 0, then integer is going to be thrown and it's going to be catched here, and then the program is going to execute this line. Now, if you actually catch an exception or throw an exception, everything below it will not be executed. So if you pass this test, then good for you. After that, you go to the second test. If you pass this test, then good for you too. So let's go ahead and run it and see what's going to happen in this case. So I'm going to make a mistake now. And again, you cannot divide by 0. Let's try to make the other one 12 and 2. And then this time I'm going to type, for example, 7. Index should not be greater than 4. You entered 7. So this is again what the catch and exception handling means. Now, you may ask a question, why do I really need to have the try and catch? All you can do here is type an else statement here. So if it's this case, show the message, else do the execution. If this is the case, show the message, otherwise do the execution. Well, first of all, exception handling by using the try block will give the people using your project the idea that this is the area where errors could happen. So it's a good for the program readability. The other thing that a lot of other programming languages use the same mechanism, but the good thing about the other programming languages like Java, as I said, you don't have to use an if statement. If this line of code caused an error, automatically an exception is going to be thrown, and it's going to be related to what is the problem that happened here. So you don't have to worry about the details about, oh, what kind of error happened and how does it happen. No, the program basically will generate that exception for you. All you have to do is just have a case for each one of them. So this is a very, very simple explanation about how exception handling works. I'm going to talk about this name one here, just to give you an idea about how does it work. Let's imagine that name should never equal ABC. If that's the case, I'm going to throw name. Now, let's see what's going to happen here. Since name is a string, and I have an integer case and I have a double case, but I don't have a string case, so basically this one is going to be executed. So if I run it, and I'll go with 3, I go with, oops, I didn't want to make that mistake. And let's go ABC. Something went wrong. Not sure what it is. Okay. Now the question is this is why we do this? Is this is why we actually ask the user where we do exception? No, basically what we do here, we can actually have a while statement, and I'll just type true. So that basically means it's going to go forever. And I'm going to go all the way down, where is it, to the catch and close it. So this is a never-ending while loop. What I need to do here before I get to the first catch and I'm still inside the try, I need to break. So what am I doing here? I'm basically telling the compiler, if you were lucky enough to get to this point in the execution, like you tested this one, it was negative, you tested this one, it was negative, you tested this one, it was negative, then basically means you didn't make any mistakes and everything went smooth. So break, leave the while loop. But if you make a mistake, go back and re-enter the values in a correct way. Okay, so let's talk about more details about how do we handle exception. Now, in general, this is not the perfect way to handle exceptions by throwing those data types, the integers. We basically do it in a different way. And that different way is by creating what we call classes, exception classes. So I did create exception class here. Let me just copy it. And I'll go all the way to the top. This is my exception class. I called it dbz divided by 0. And this divided by 0, I do have a public that members integer x, and I got the constructor where I'm going to receive an x, I'm going to assign x to x, and then I have a message function which is going to return a string, and I said return. You cannot divide by 0. So what I'm going to do here, instead of actually throwing b, I am going to throw a BVZ object. Where is it? Now, here's what we need to do. Since I'm not using b that much, I actually don't need this x here. I don't need this x here. And I don't need anything here. Just keep it simple that way. It's just going to return a message. And then in this area, instead of E1, BVZ. This should go away. Type is not allowed. Why are you saying that? There, here. That's what I expected. And here we go. So you can see here that I don't have to actually pass an integer anymore. I'm passing an object of that PVZ. And this message here, there's no need for it to be printed as it is. This is what I'm going to type. I'm going to type E1 dot message. And then end line, semicolon. Let's take this one away. So you can see here, I changed, instead of passing b, I'm passing divided by 0. So that basically means if I'm going to divide later in my project by numbers, I can call that every time I do that. Let's go ahead and check out the other one, which is here, error index. Let me cut it. I'm not supposed to cut it, but it's okay. I'm going to put it here. And as you can see here, this time I'm going to pass an x. I'm going to assign x to x, which is the index, and I'm going to show a message. Look at the message that I'm going to pass. Index cannot be greater than 4. You entered, and x is going to be converted to a string to be added to the original. Just like we did before. This time, where is it? And instead of doing it this way, we're going to do it this way. And the same thing is going to be applied here. And instead of all this, just go ahead and type e2.message. And that should fix the problem. So I'll just go ahead and make a mistake. You should not be divided by 0. Oh, you're giving me another chance. And now let's make a mistake here. 899. You entered 4. No, I didn't enter 4. Let's go ahead and try to fix that. Why is it telling me that I entered 4? You entered 4. No, that should not be the case. I entered... Oh, let's see. What am I... Where is it? Index of 4. Yep. Index it in 4. Okay. No mistake at the beginning. And now I'm going to enter. And here we go. No mistake now. No mistake. No mistake now. And let's put 3. And that worked. A, B, C. Something went wrong. Okay. So as you can see here, you should be able to create your own classes for those errors, or there's another magic solution, is to actually include a very special header file. It's called exceptions. Let me just make sure I do have it here. So this standard exception, this is the structure of this exception header file. It has all these classes predefined for you. So if you want to use any of them, just go ahead and include that exception header file. But again, it's not that easy. You need to actually understand how each one of them works so you know how to throw it. And I am not going to talk about it right now, but should not be that complicated. So you can actually include exceptions, and instead of actually creating your own, you can call them if your case is covered by any of them. Now, to be able to use any of them, basically you just need to go to the documentary of it, see how does it work, how do you catch it, and how do you throw it, and what kind of methods are associated with it. Okay, now let's move on. And the last part I want to talk about in this video is what if I have a method? For example, here, instead of this, I'm just going to do this. I'm going to come here and say name equal let's say my function, and I'm going to pass name to it. So what I'm saying here, after I'm reading name, I'm going to go to and use it inside a function, and let's just put an integer here. Integer, let's call it x. And in this area, I'm going to show name, and I'm going to show x with a space between them. So he's complaining he doesn't know what is my function, so let me copy that. I'm going to go all the way to the top here, and it'll return an integer. It's called my function, and it has a string parameter. And in this area, all I'm going to do, I'm going to say if, just like we did before, name equal ABC, throw name. Otherwise, if it's not that, I'm just going to say return x. Well, we don't know what's x, so I'm just going to return 76, for example, to be returned. Now, the only part that's missing here is whenever you have a function that's going to throw an exception, you need to come in this area and type throw, and you type the data type string. So since I'm throwing name, and name is a string, so I have to put a string here. So what's going to happen when you call this function here, where is it? If this function executed normally, you'll get x back, and you will see that the name and the x are going to print it here. But if exception was thrown here, that exception that's going to be thrown here is going to be catched by this one. So I'll just go ahead and run this. I'm not going to make any mistakes for the first two options. So 12 and 2 and 1, 1. And here I'm going to type ABC, and you can see something went wrong. Let's go ahead and do it again. This time I'm going to type my name, and you'll see here, no exception happened. And that's how it works. So this is basically what exception handling is. It's not that complicated. It's a lot easier comparing to other programming language because it's very simple comparing to other programming language. It doesn't handle it as well as other programming language. My problems with exception handling in C++ is the fact that I need to have an if statement. It's a lot easier than Java, of course, when it comes to the syntax and how does it work. But the problem that I have with C++ exception handling is the fact that I need to have an if statement, which basically means that I can get the same job done without using those try and catch blocks, but it's a lot better to use it for improving over the readability of your code. And again, you can throw, what I can do, I can take all these catches away and just keep one generic one. So if anything go wrong, just show me this generic message here. This will be the end of this video, and I hope you guys have a good day.